All right, so if we increase O2, oh no, I didn't figure the answer out. I would believe you. So it goes to the opposite side because we added. Okay, it goes to the opposite side because we added. Okay, that's the same thing as adding, right?
Oh, yeah, that's what it meant.
Okay, the concentration of O2 is increased. Is the same thing as adding something. Okay, adding a reactant, adding a product. So we added something. You guys on the light bus? Okay, your psychology thing's on my desk, please. Okay, so we're adding some oxygen. So you said it goes to the opposite side. So we shift. Right. So that means it's going to decrease on this side. It's going to increase on that side. So I asked what happens to the concentration of NO in all three questions, right? So what happens to the concentration of NO in question 1? It increases. So number 1, the answer is increase. All right, question 2, I'm asking about pressure. So what do we have to know about pressure? Moles. How many moles are on the left? How many moles are on the right? So what happens to my NO? No change. So no change for number 2. All right, and number 3, what happens if temperature is increased?
You add it to the left.
Okay, what's the rule?
You add it to the colder side.
Okay, so if temperature is increased, it goes to the colder side. Okay, so what side is the colder side if the heat is over here? Okay, so it's going to shift to the left. Okay, so if it shifts left, that means it's going to increase here and decrease there. So what happens to my NO? It decreases, is correct.
Do you have any
Several. Now I just have late bus come in and got 2 from the late bus. Huh? You remember 9? I have many. I'm recording, please. Huh? That's fine. That's not mine. That's not what I'm praying for. I'm praying for the facts here. You know what I'm talking about? Woo!
What happens is they come to you don't have to go the full day and they get on the course.
Don't tell them that, please. Yes. So if you need, so for example, this one temperature was increased. You want to go to the colder side. You want to go to the side without the number. So if I had said temperature was decreased, you want to go to the side with the number because you need to go to the side with the heat. So you would go to the side with the number.
Increase is opposite.
Yes.
And
Yes.
the pressure is just with moles.
Yes.
Increased pressure, you go to the less moles.
Yes. Yes. And because this one has the same number of moles on both sides, there's no change.
And the concentration.
Depends. So this one, because I increased, we had to go to the opposite side. And if I remove or lower the concentration, you go to the same side. Yes. Yes. That is correct. All right. Questions about the oven? The opening, like right back. You tend to write everything you know. Huh?
Yeah. Come on.
I feel like this would be a first year in this class.
Yeah.
There's not all that way though. That's
I don't know why the body of my kids like this.
and it's not even that they're just as full as I have.
My cousin's back in the 18th of the art teacher, and 1 year they were making him over and he had his laptop out. And he was just like looking through the research paper and not knowing what kids were on. And he was just like sitting in a chair, like with his finger doing this, and like taking his finger like separate song, and he was.
I understand. Yes, Victoria. On your lowest test. Well, it's on the last test, really. It's not even on the lowest. It's just the last test. Now, we are done with the material for the test. Okay? Theoretically, we would have tested today had today not been an early dismissal day. Okay? So we will not test the first day we're back, which is Wednesday. We will test when? Thursday. So I'm not assigning any homework over the break. You know where you're at academically. Okay? If you're all good with I don't need to do anything, my test is Thursday. You have no homework. If you're in the category of, oh crap, I don't like my grade. So I really need to do well on the last test. Plus I have those bathroom points. I need to get as high as I can because I need to see what I can do to increase my grade. Then study before you get back so that you're not as stressed Wednesday night. Okay? So on you. Our exam is the first exam. Our exam is the Friday, the 12th. Okay? Everybody else has a 3-day weekend, and we come back to exam. Y'all are the first. Okay? We're going to review when we get back. Okay? Most likely, I'm going to take the Thursday we get back, and then I'll pick 2 days the following week. Probably the Tuesday and the Thursday again before exams to do reviews. So, Mr. I have to work. If you just talk to your boss and say, Ms. Wallace can offer me reviews, my chemistry grade is important. Can you work with me? Okay? I'll be done by 4:30. You can be at work by 5. Okay. There you go. I'm not written on the board, probably not going to today. It's the day we'll get out for Christmas. Not feeling very hard working today. So if you want, here it is. Probably not even writing it up there for you. I'll write it up first, here it is. So, anyhow, are there any questions before we move on to a new topic? Fabulous. I'm so happy to hear y'all say that. We're moving on to a new topic.
What? I thought this was our last time.
It is. Doesn't mean we're done teaching, just means I'm done giving tests. Does that mean that you will not see a quiz? Either, by the way. This means you won't see the test.
This long. This is green chill right here. You know what flavor it is?
Why?
It's grape. No wonder I don't like it. I hate grape flavored stuff.
All right, you need your blue table today, blue chart. So, find your blue chart. We're going to talk solubility and precipitation. I don't know how far we will get in solubility and precipitation over the next week. We will at least do precipitation. We will do solubility and concentration. Acids and bases are a complete loss. I'm going to teach you some things for review depth. That's what I can do. Okay? I hope I'm going to at least get some nuclear in review to help you eliminate some stuff. Because that's a really easy pop. Okay? Most likely. Now, get my thoughts together on how I'm going to do this. Wave 2.
I have a question. Why, when we're celebrating independence on the 4th of July, why don't we say it July 4th on the regular American Day? Why do you guys say the British for the 4th of July?
Should I know? That's exactly what I'm thinking. I ain't having a meat. All these old strays.
Guys, is that the song? What is that? It's a really old movie.
Like ancient.
It's not, it's like the 50s. It's like a French.
I reiterate, ancient.
Wait, the Wolverine not supposed to Alan? Yeah, okay. You're just supposed to be questioning.
All right. We're gonna go from that angle. All right. So, what does it mean to say something soluble? Okay. So,
It's like water is a universal solvent.
That's what I want to see. What y'all didn't know.
That's it.
That's all you know? Okay.
Then,
All right. So, what symbol are we gonna give it?
S.
No.
Triangle S.
Huh?
That's with the line over it.
I'm thinking something we learned this semester, and that's not something we learned this semester. Something we might have learned maybe when we studied chemical reactions. That
How
might.
about an arrow?
That's like yield.
Yeah, but
How about
like
that? There we go.
I do that. Never mind.
Okay. Now, we're also going to talk about insoluble today. What does insoluble mean?
It can be dissolved.
Okay. So, what symbol are we going to use for it today?
Solid.
Very good. Okay.
Okay.
Cheers. So, we're going to have solid and insoluble today. We're going to limit ourselves to solids for today. We will move towards liquids and gases after Christmas break, but we're going to stick with aqueous and solids today. So the first thing we need to figure out is, how do we determine if something is soluble and something is insoluble, which is why I said you need your blue chart, because you're not going to be able to figure out this on your own. The state is going to provide this information for you. Yes, my dear?
Activity theory?
No, solubility rules. Okay? We could use the activity series, but that would be really hard.
Well,
Yes, ma'am?
the Jordan comes to Adams,
Which one do you want? I got two. Let me ask that first. Huh?
Beggar.
She's not here as usual.
Okay, thanks.
Welcome. I can stop being so. Salty's the right word for that. Okay.
No, it's awful.
Okay. What was I gonna say? What are you talking? No. It's only physical. Yes. What? As long as it's not heavy rap with a lot of foul language, I'm fairly flexible.
No, okay. So, like,
Yeah. And that really goat yodeling country I struggle with too that my daughter likes.
Go, yo.
Huh? I know.
But,
And I do live in the West Davidson district, and I grew up listening to country music. But as I have aged, I really get to the point that I get sick of it. Yeah. No. We're getting ready to talk about how it has nothing to do with the formula. What?
I really want to like play music and like that's why you like this. Like,
I know, I get that all the time at home too. Yeah, I do, a lot.
Like artists, like my mom's really into like Carol King, like not too much.
No.
What is that? What is that? Carol King. Singers songs like it's in your song.
I know who Carol King is, and no, she's not one of my favorites. Now,
Queen, the band,
huh?
like Freddie Mercury, like.
Oh my God, please say you like Queen.
Okay.
Yeah,
I'm not going to say they're terrible, but they're certainly not going to hit my top 10.
You offended me.
I'm so sorry. I like Star Wars. Does that count?
Yeah.
All right. So, find your solubility rules on your blue reference table. So you've got them handy. All right.
Oh, it's right here.
All right.
Don't think you
There you go. So, to determine solubility, we use the solubility table. Now, the problem we have is how to read it. So, some people pick up on this very quickly. It's not an issue. Some folks struggle a little more. So, let's just say that we have something like NaNO3. All right? You read the table using the anion. Now, what is the anion? This is an old vocabulary word. The negative ion. Okay, very good. So the anion is the negative ion. So what is my negative ion in this formula? That's right. Negative ion is this right here. That's right. The negative never goes first. You look up the NO3. Now, the positive ion, which is called the cation, is used to determine the exception. Some of the rules, you will notice, say except. Some of the rules don't. You use the positive ion or the cation for the exception. So this right here is the positive ion. It's used for the exception if there is one. Some of the rules have a positive ion exception. Some of the rules don't. You just have to read the rule. I picked a very easy one to start with. Okay? So, if you don't know what NO3 is, what did we say we could do? Because you don't have an oxidation sheet. That's exactly right. Flip your chart back and forth. If you don't know what NO3 is, because these are all written out names, flip it to this side. What is NO3 if you don't know its name? Lots of you already have some of these polyatomic ions in your mind. It's nitrate. Okay? So if you're not Daniela and you didn't remember, oh, it's nitrate, then flip over here and find NO3. And NO3's name is nitrate. So when you flip back to this side, find the rule that says nitrate. Now, what did we just say before we go any further? Soluble is going to get what symbol? Aqueous. So if we're in the column that says soluble, we're going to put what beside it? Aqueous. If we're in the column that says insoluble, we're going to put what beside it? Solid. Okay, so now we got to read the rule. So NO3 is nitrate. What does it say about nitrate? All nitrates are what? Y'all just staring at me. All right, let me minimize for a second. Taste this in.
It's soluble. Oh my goodness.
That's the important skill to have. Sorry for the skills.
Oh, I just feel this is a little outside part more to the bed.
You know what, my aunt actually went to Mexico last night and my other aunt going to Mexico today.
When you say that, it's like going down to like 2 days. Alexis is texting me all the way from Mexico to Michigan.
She what?
Texting me all the way from Mexico. Wait, she's in Mexico.
She needs to get
Like, I
it.
knew she was gonna go. I didn't know she was already there.
She needs to get it. All right, so we look at this for those of you who are struggling. All right, it says all nitrates. All nitrates Okay? So when you read this, all nitrates, acetate, ammonium, and group 1 salts at the end in your head, I want you to read it as are soluble. Don't write that on your sheet. Okay? But in your head, hey, Miss Floyd, what's up? It's all right. They're terribly crushed. So you just interrupted class. So sorry. I have got the number. I'd be willing to ask Miss Chelsea if it's okay if I give her number to somebody.
Or we could ask her,
Did she make the school
Right.
visit?
when we ask her.
Yeah. Let me make myself a note to do that during next year.
You can do it right now. Like, I don't have to try them, but
Okay.
if you just ask her, if she said something. Don't say it's good. She was the last one tonight. I know you went on to Midway. It's going to be hours and
When my dad grew up where that's it, I went all.
Okay. Yeah. I'll be glad.
Okay, thank you so much.
You're welcome. Anytime. All right. All right. Solubility rules. All right. So all nitrates, acetate, ammonium, and group 1 salt. So in your head, you're going to read that as are soluble. Okay. So when you go back to your compound, is this soluble or is it insoluble? So behind it, you're going to write a U, and you're done. The reason we don't have to look at Na is, did it say except anything at the end of it? You're done. All nitrates are soluble. There are no exceptions. Now, what if we have a compound such as ZnCO3? Okay, what is CO3? I didn't say you were wrong. I just looked around the room. Everybody else is still looking. You're just shouting out stuff, and they're all just sitting there. You are right. Okay, so it's a carbonate. So if we cruise back to carbonate, find carbonate in the list. Where's the carbonate? It's on the insoluble. Okay, so it's over here. So again, I want you to read it, and at the end, I want you to write in your head are insoluble. Okay, all carbonates and phosphates except group 1 and ammonium are insoluble. So all carbonates are insoluble except group 1. So this is going to be a solid unless this is in group 1. Is that in group 1? So it stays a solid. If that had been in group 1, we would change this to what? We would change it to aqueous. Okay? The rule, does everybody understand what I'm saying about reading the rule?
Yes.
Okay? It says all carbonates and phosphates are insoluble except group 1 and ammonium. So, if this is group 1, it's an exception. So we would change this to what if this had been group 1? We would change it to aqueous. Okay? So, suppose for just a second, I have Na2S. Suppose I have this one. Okay? What's that? Sulfide or sulfate? How do you decide?
Because it doesn't have another,
Doesn't have enough letters to be sulfate. How many elements does it have? Got two. So it has to end in what ending? IDE. Okay, it's a binary compound. So it ends in IDE. That's how you know it's sulfide. Okay, so read the rule and tell me what you think.
All sulfide except this one, and then they can go. Yeah, all sulfide except this one.
All right, so I hear some aqueouses out there. All right, so if we look, sulfides are here. All right, so all sulfides are solid. Okay? Somebody said aqueous. Why would we say it's aqueous if it's under the solid category? It's Na, and it says all sulfides are solid except group 1. And where is Na at? It's in group 1, so we're going to change that to aqueous. Everybody's like it. All right, questions about how to do that? Think you can try some?
Yes.
All right, because you got to be able to do this to do precipitation reactions. Let me find my example so I don't have to make these up off the top of my head. Because I'm lazy that way. It's the week of Christmas. It is, and I admit wholeheartedly to being lazy. All right, no problems with that. Huh? Sure there is.
The only motivation I have is after school, I gotta go take the clothes to the laundromat, get some hot chocolate, and leave.
You made me take this up and grade it today, and I'm going to be pissed. So there's your motivation. All right, do those 5 real quick. And then we're going to talk about dissociation and precipitation. We're not going to get to finish it, but we're going to get started. Thank you, my dear. Four periods we just guessed at the door.
No, I said my skills.
How does that work? Like,
Notice how quiet it
Why?
is. You need to take it easy.
How many isn't it?
Kind of 25, 15 to 18.
So it's just a couple of.
But other people, I just a handful.
Like literally a handful. That handful cost.
And you can probably take out 5 and make your 6 from.
I get it. When you say a handful, then you have the number in your hand. Probably.
Yeah.
Oh, that thing's so upset now. You know,
All right. So KNO3, what did you come up with? It's aqueous. All nitrates. All nitrates. Doesn't matter what it is. All nitrates. There are no exceptions listed here. All nitrates are aqueous. Are aqueous. All right. Sulfides. Solids. The only exception listed is group 1, and is it group 2 too? I don't have the paper in front of me.
No, it's
Just group 1, I think, and ammonium,
It's just group 1.
and group 2. All right. Iodides. It's aqueous. It says silver, lead, and mercury. Is that silver, lead, or mercury? No. So that means it stays aqueous. All hydroxides are, I'm just going to say they're insoluble except group 1. So it's an exception, so that's why it becomes aqueous. All sulfates are solid except for calcium. It's listed specially, so it's aqueous. All right. So I gave you several that are exceptions.
Wait.
What?
Wait. I want to be solid to be solid.
Oh, it is solid?
Yeah. Because I got confused.
That's what happens when the ball doesn't use the shoot. Make sure we're doing it right. All sulfates are.
Except calcium, sodium, and mercury.
All sulfates are. Where are we at? Are soluble, so AQ, except for calcium. So it's gonna make it a solid. That is correct. It is aqueous, but it's an exception, so it changes it to a solid. That goes the other way. Out west. I went to Wyoming and the Grand Canyon. I'd never been out west. I've been to Hawaii and places like that.
We love Wyoming.
I would love to go back. I would love to go back. I'd probably move out there, but my children would kill me. All right, questions? Not long. So, questions? All right, moving on. Let's talk dissociation. This is the last piece we need before we talk precipitation. Dissociation. All right. What is dissociation? Dissociation occurs when an ionic compound dissolves in what? Dissociation occurs when an ionic compound dissolves in what? Now, it sounds like it would be really complicated, but it's not. Okay? Dissociation just means that an ionic compound breaks into ions. Oh. I don't know what I did. I agree. Even I just want to sit down and not do anything. It goes against everything I believe in, Ethan.
Well, sometimes
You want to know what that thing's a little buggy?
I was sitting in the hall this morning, and everyone was bringing me snacks and stuff, and I must be, I'm pretty sure like one of the only people doing. No, you're not.
There, makes you feel better.
Krispy Kreme and cookies and
It's a Jessica is going to watch this. I'm hanging on to that. This is pretty good. We'll keep that promise.
If it makes you feel better, I started teaching here when parties were strictly forbidden of any kind.
You know, before conducting the action, after exams, we're allowed to not come to your class. I'm a student. Now I'm have my own party
Okay.
You go back up to school? Yeah, back to school.
All right. So we have assaults, such as NACL, and we need to dissociate it. What does it break into? So, how do we represent that?
And I make one.
Okay. Now, we need to show that as ions. So, how do we show that as ions? All right, it needs a +1 and a -1, and they need states. They're ions. Just what do you think ions are? Okay. All ions are aqueous. And they're not diatomic. So, all those times y'all have been hollering at me, Miss Wall, put 2 on there. When they were ions over the course of the last few weeks, and I kept saying, we're going to get there, we're going to get there, we're there. Okay?
I didn't know.
If it's dissociated, meaning it's breaking apart from a solid into ions, then it's not going to do that. Okay? You're not going to have to worry about that. If you're double displacing or single displacing or something like that, synthesis, then it's going to be something that's going to be diatomic, and you're still going to put the 2 on it. But if you're breaking it apart like this, it's not going to get a 2. And just remember, I'm getting old. Talk loud enough if I can hear you. Yes, but it won't be called dissociation. It'll be called ionization or something else. Dissociation will be a solid. It has another name if it's another state. Okay? So, let's say that we have something like MgCl2 as a solid, and it dissociates. What happens then? Essentially, except they're ions. Yes. And put in there what? Okay. And they're both ions, so they're both aqueous. I need one more piece. Very good. So,
How do you know the difference between dissociation and
because it's going to say something in the question, it's going to tell you it's dissociation. All right, how many moles of ions are formed? How do you know? There you go. Everybody okay with Emma's answer?
Yes.
Okay, apparently understand that color. Apparently I'm not writing it all. I did. Okay? Now, is everybody okay with how Emma got the answer? How'd she do that? All right. How many moles are here? 1 plus 2 is 3. So she said 1 plus 2 equals 3. Okay? Because it said form, there had to be what? There had to be products. There had to be products because it said form. Does that make sense? Yes, that is correct. Everybody with me? Now, so far, everything we've done has been building up to the main point of the lesson, which we're going to focus on really on Monday, or well, I guess Wednesday when we get back, because it's a Wednesday we start, not a Monday. Okay? Now, normally we would do a lab with this, and I'm still kicking around whether we're going to do a lab because we're really behind, and I don't think we're going to have time. It wouldn't have a lab report for y'all get bent out of shape, but I'm probably going to can it anyway. All right, so precipitation reaction. All right. The nice part about doing these, and one of the reasons I'm still doing them today, is they're essentially double displacement reactions. But there's 2 parts that we're going to learn today, and Monday when we come back, that are not something we've learned, like spectator ions and net ionic reactions. If I was going to take a gamble on what you would see if I asked you this, because remember, there's only 45 questions. I'm taking a shot in the dark on what they're going to put on the exam and what they're not. My greatest fear is that you'll have 4 questions on what we haven't learned this semester, just because I can. I don't know what we'll be able to test because I never get to see the test.
Remember all this stuff. You only give us 25 questions.
Dig, dig, dig. Which drives me insane. All right, so what is a precipitation reaction? Now, first of all, we've already talked about precipitate.
Does it happen whenever you have a reaction and it's that explosion?
We did this way back at the very beginning of the semester.
That's still vector.
Huh? So what is it? Okay, and we're going to alter your definition because now y'all are more sophisticated.
Create a problem.
Okay. 2, aqueous liquid. 2 aqueous liquids form a solid. Let's say that mix and form a solid. Okay? So we're going to mix 2 aqueous liquids and we're going to form a solid. Now, because you're in a first year class, you're not going to mix 2 aqueous liquids and get nothing. You're not going to mix 2 aqueous liquids and get 2 solids. You're in an AP class, yes, you could get 2 solids. Yes, you could mix something and get no solids. You're in a first year class. You're going to have a standard reaction where you're going to get 1 solid and 1 aqueous.
Yes.
Okay?
Yeah. Love it.
You could get mix 2 aqueous and get 2 aqueous where you got no solids. You could mix 2 aqueous and get 2 solids. You're in a first year class. We're not going to do that to you. So if you write a reaction and you go, dang, neither of these make solids this wall, the first thing that should run through your head is, this is wrong, I did something wrong, or I got 2 solids. I didn't get any solids. So I ain't right here, okay? I should get 1 solid, 1 liquid, or 1 aqueous every time.
Yeah.
Okay? One's going to be deadline and solid, the other's going to be a liquid, it's going to be spectator ions, just float around there and do nothing. Right? That's what spectator is. Now, you can take the solid, you can react with something else, but it's dead until you do something else with it. Okay? Now, Let's talk about what we're going to do. So we're going to do three things. We're going to take double displacement reaction. We're going to find its net ionic, and we're going to find its spectator species. So let's begin. Let's take barium nitrate and potassium sulfate. So you getting out of here shortly?
Yeah, and then
Soon.
Not that.
10, got 10, my bad.
It's soon. All right. So if you had this earlier in the semester, what would you do? Either 920 or 925. Is that what it is?
That's the question.
What did you do first? What would you have done way back about? Good God. Double displace. So how do you double displace? You got an exam coming up. Prayer is important. That was not what I was hoping for an answer, though. You switch the. I heard you switch the positive ions. I like that answer. This thing is like useless. What the heck's the bell schedule in this thing? All right, so plus 2, minus 1, plus 1, minus 2. Switch the ones that have the same positive or the same negative oxidation number. Doesn't matter which one we pick. No. So who's switching? K is switching with BA. So K is going to be where BA was. So K is with NO3. And BA is with SO4. So, what I need to do now? Very good. Plus 1, minus 1, plus 2, minus 2. Those all canceled out. That made it nice and easy. So, for those of us who need steps when we come back from break, I double displaced, switched oxidation number. Now, here's the new piece. Put in states on product side. Yeah, they're already on the reactant side. Okay, so you have to find the states on the product side. That's the new piece that we're doing today. So you got your sheets handy?
Yes.
See if you can figure it out. Well, I'll see if I can find out if we get out of here at 9:20 and 9:25. Because this professional guide they gave me is like useless as chips on a boar hog.
I don't even know what that means.
A boar hog is a male and it's never going to need chips because it's never going to have children.
I love that.
No,
no,
we never
recorded.
recorded. Watch the video.
That's because I got all this
What are you?
super extra useless stuff in this professional guide. You would think we have bell scheduling. I'm looking on the website. I ain't got time for all that. Maybe I put it in this notebook last year like I was smart for subs. In case I had to be out once upon a time. Bell schedule for that one. Yes, 9:20. I was smart. Much smarter than whoever put that thing together. 9:20. All right, so what is state for KNO3? Very good. We're going to put aqueous there. And what is the state for that one? Solid. Okay, everybody there. Okay, so we're going to do the next step in the process, and it might only be as far as we get, but that'll lead us to the two things we need when we get back. Now, step 2 is the one Step 2 is the one I call the work step. It is never the answer to anything, but it is the step that leads you to the other two answers. Okay? And it's why I taught dissociation. Okay? You dissociate all aqueous compounds only. Okay? So, who am I not dissociating? First of all, the solid. Okay? So, I'm going to rewrite BaSO4 as a solid. I'm going to rewrite that right there. I'm not going to do anything to it. Everybody else I have to dissociate. So, Ba plus NO3 plus K plus NO, SO4 minus 2 yields. On the other side, I got K plus NO3 negative 1. And all of those states were what? What states were all of those? So all of these are still aqueous. Now, from the work step, I can get my net ionic and I can get the spectator ionic. Okay? The spectators are the easy ones. The spectator ions. Or what cancels out. What's the same on both sides is going to go away and cancels out. They don't do anything. The K is a spectator. Who else? And NO3. Those are your spectators. K plus, aqueous, and NO3 minus 1 aqueous are your spectators. Now, your net ionic is everything that's left, which I'm not going to take the time to write down because I need to quit. But if you recopy everything that's left up there, if you rewrite this, plus that, down here, that's going to be your net ionic. Okay? Now, we will pick this up after break. It's not hard. You're basically doing what we've already been doing. So we're just practicing some things we've already done and re-looping it before the exam. Okay, we'll do solubility. We'll test on Thursday. We'll bring in some more solubility. We'll do some new stuff next week. We have very little time to review. Look at your schedules for Thursday when we get back after school for review, and look again for the following week for like Tuesday and Thursday. Okay? Have a nice Christmas break. Please try to be safe. Huh? See you next year.
When you see me again, I will be 17.
Okay? Well, happy birthday over the break then.
I'm the one you know. I'm older than me. I was here along in Constance Place with the years and that. What is that one?
Y'all sounding seriously old over there.
I'm still stuck at over